Okay, so the next problem in the lead code we are solving is sum root to the leaf numbers. Okay, so basically what is being asked here is we'll have to build a path. Okay, so it's like 495 491 40. Okay, if you concatenate it, and also it's been given that it's a all these numbers are from 0 to 9 only. Okay, there is no 2 digit, everything is a single digit number here. And if you concatenate, like it's 495 491 40. Okay, if you concatenate it, it will look like 495 491 40, right? These are the paths, and finally what we need to do is we'll have to take a sum of it and we'll have to return it. This is the problem. Okay, so now let's see like how we can do it. So if we are aware how to build the paths, right, then it's a straightforward thing. Okay, we'll not go for that part, but let me just quickly explain how to build the paths. Okay, so that it will be easy to explain further. Okay, so how are we going to build a path, right? Like basically what is meant by path here is, so this is one path, correct? 495 is one path, and 491 is one path, and finally 40 is also one path, correct? So now when we are building the paths, when I'm here I should be able to go back or something like that, right? I should be tracking that path, that's what it means. So let's say that it will be, once again let me rewrite the tree. Okay, I just rewritten the tree with the characters because that will be easy to understand how we are building the paths. Okay, so basically, if you understood how to build the paths, right, this is a straightforward thing to solve this problem. Okay, there will be slight little change in the end. Okay, so now let's say that how we are going to, we know that this is one path, A B C A B D A E. These are the paths, right? So if you are able to return the list of paths, then we can finally have to take a sum of it. Basically, currently we cannot take a sum for this one because this is a character, right? We cannot take it. So let's say that, let's understand how we are going to build a path here. Okay, so what is meant by building the path is, let's say that if you are traveling from one place to another place and you are keeping a track of it, like I mean let's say that you are going from city A to city C, you will know like what is the path, right? You came from city A, you came from city B, and finally you reach the city C. Okay, city, when you reach the city C, you should be knowing that you came from A and B. Okay, so how does that work is, so obviously when you go to B, you should know that you came from A, correct? So that will be one path. Okay, and finally when you go to the C, you should tell this guy that you should tell this guy that I come from A, and when you go to C, you should tell this guy that I came from A B. Okay, it means that I started from A and ended at B. But ultimately, the leaf node can make its own calculation, the final city calculation A B C. This is how we are going to build a path. Okay, so ultimately, once this side path is done, we'll also have to build a right side also, right? So that's why I will tell again this guy that I'm traveling from A, and finally this is the leaf node, this is the destination. So what he will do, okay, A is the final path. Okay, so now we got to know that. Okay, so now it can be list of paths, right? So what we'll have to do is, like I mean he again this guy will also, let's leave this guy ABD, he will be returning this guy. Okay, ABD is also returned now. Okay, so now ultimately when we see from here, it's a list of paths, correct? One is this one ABC and ABD, and one is AE. Like these are the list of paths that this guy will be returning. So we will collecting all the list. Okay, so once we got the list, okay, we'll have to take a sum in that current problem. Okay, so let me just quickly replace it. Okay, I just rewritten that. Like I mean, previously those were ABC, right? I've just replaced with the numbers now. So this will be the path, correct? 495, 491, 490. We built a path. So ultimately, what we need to do is we'll have to take a sum in this problem. Okay, if you understood how this path building worked, right? I mean, telling the like they are passing the current path to the next one, and he'll pass the next one, and finally we'll be building the path, right? And ultimately we'll be returning the list, correct? So why, like I mean, you will get there might be a question that why didn't we return a list here, like while solving the problem. The reason here is, like let's say that we are right, it's a list of paths, we don't have one path. So it's not like single value that we are returning, it's a list of paths. So that's why we need to make sure that wherever, like let's say that we are going to write a recursive function now. So that function intention is to always return a list, because that should be consistent, right? We cannot return, let's just because we it found one path, it like I mean it should not return only one that value, right? This path, it should be always written in the format of, even though if it is a one value, it should always return in a list, so that it will be helpful for our calculation. Let's quickly check how that helps. Okay, so first foremost thing is we'll be building the path. Okay, first let's this function, and finally we'll be taking the sum of it. Okay, we'll come to, that's a straightforward thing. So build path, initially we don't we'll be starting with the root, and we don't have any paths, right? That's the starting point for our city. Let's say that as we discussed, we are going from A to C city. We haven't traveled anywhere, so it will be blank. Okay, So it's these are like some basic condition. If there is nothing, we'll have to return empty, and also we'll be returning not none this time. It will be returning the empty list, so that it will be helpful for us to take a sum, right? So sum will be 0 or something like that. Okay, I think it will error out. Okay, let it be. Okay, so now no dot left is equal to none. Okay, we'll have to identify. Okay, let's come to this later. So what we'll do is we'll have to build a path. So what we are going to do is we'll build the left path and also the right path, because here we need to know 1 2 and 1 3, right? We need to build both of the trees. So first we'll ask the left guys to build a path. Okay, this I will consider this as a main guy. Okay, let's just go to I will this will be the main guy. I will ask the other guys to build a tree for me, build a path for me. Okay, so build a path. I will ask send the next node. Okay, I will send this node. But when I'm sending this node, I will tell this guy that whatever the current path built so far, whatever initially it was a blank one, and I will add myself, like I mean a will be city, a will be added. Okay, and the left path like I mean 4 9 will be aware that okay, this has reached a 4. Okay, similarly right pass, when I'm doing the right pass, it will 0 will know that okay, it has reached 4. Okay, so once this is done, right, so at the leaf node we'll be doing our calculation. We'll be actually this is the conversion needed because of concatenation, right? We need to concatenate it. So once we concatenate it, we can actually use the formatted string or whatever, right? I just made it a string. Okay, so once that is done, we'll finally build the so far the path, and we need it in an integer, correct? We don't want it in a string because we cannot add it at the end, or we can have a separate calculation to convert all the strings to the integer, but that's an extra thing, right? We can just do it here itself. So we can just say that integer of conversion, and remember here we will be returning it as a list. We could have returned it here, but ultimately when you go to the top right, when you see it from here, it's a list of paths you see. Here when you see, it will be just one path. Okay, here when you see, it will be just one path, but at the top layer you should will be getting the list of paths. So that's why we need to ensure that you will have to return it in a list format. Okay, ultimately left path will return some paths, and right path will return the path. And it's like this is also list, this is also list, but we are not interested in list of list. Like we just need the number of numbers here, so we are destructuring it here. Okay, we are destructuring it. Finally whatever the values that we get, we'll be getting the pass here, we'll be taking the sum for it. That's it. Yeah, thanks. You can just read this note also if it helps. Okay, that's it. Thanks.